First, let's understand with what data is. Obviously, we have discussed it already. And as per our discussion, we know that information stored in a digital format, which can be used as a base for performing analysis and decision making. Just is data, and data is divided into, basically data is of two types. One is traditional data, the other is big data. So traditional data would include table containing texts and numbers. So mostly when we talk about traditional, it is stored in Excel and we work with Excel. And it is stored in databases in a structured manner. This is very important in case of traditional data. It is stored in a structured manner. However, when we talk about big data, they are huge data which can be in three forms. That is structured, semi-structured, and unstructured. And that is how we differentiate between traditional and big data. Also, one very important thing about big data, that there are V's of big data. So this V's could be 3, 5, 7, or 11 in number. Now, let's discuss about the V's. This is important as a BA. So to start with, first is vision. So vision about the big data or the project that we are dealing with. So we need to have a fair understanding about the vision. Then value, that is the value that big data carries. Then comes visualization. So here we use visualization tools such as Power BI and Tableau. Then comes variability. Variability would mean consistency of big data, how consistent the data is. Then comes volume, and this volume means huge memory space that is basically required to store such big data, whether we have enough resource or not. So we have to understand that part. Then comes variety. Now this variety is images or the audio file or video file, the format in which we receive such data. Lastly, it is velocity. So while working with big data, one's goal is to make extracting patterns from it as quickly as possible. And the result is that the output should be in real time after extracting such data. I hope this is clear. So we have data divided into traditional data, big data. Difference would be in traditional, it is structured data. Here it is structured, could be semi-structured or unstructured. And 3 V's, while before we work on big data, we should understand these V's. So it is divided into 3, 5, 7. It will all depend upon the project. If the project is small, we are good to go with any 3 V's. But then we cannot really go out of these. All right. After data, let's just try to figure out data science, which obviously means that it combines statistical, mathematical, analytical, problem solving, programming, and big data management tools. So these are the things that we have discussed already. I'll just repeat. In data science, we use statistical, mathematical, analytical, problem solving, programming, and big data management tools. And so we divide data science into three segments. So the first segment is business intelligence, or BA. Second is traditional method. And third is machine learning. Okay, so there's one important thing that we can understand right here if there's any confusion. BA, business intelligence, is part of business analytics. So it is everything about analysis or past data. When BI is clubbed with analytics, it forms business analytics. This is the only difference. So whether we call it BI or BA, we need to understand the only difference is about past and future. That's it. So as data science is segmented into business intelligence, traditional method, and machine learning, let us understand that the first step here is BI. So in the whole data science, there comes a very small segment that is BA, and that is why BA is different from data science. Because data science also includes traditional method and machine learning. So the first step is business intelligence, that is to analyze past data. So step one is to analyze the past data. It includes all technology-driven tools. So these tools are involved in the process of analyzing, understanding, and reporting available past data. Okay, so we at least know that here we have to analyze, report, and analyze, understand, and report. Obviously, understanding is important. So this BI, or the first step, when clubbed with BI report plus BI dashboards, so here we will be using Tableau and Power BI. So this will give informed and strategic business decisions. So informed insights. So here it helps us in extracting insight or the ideas. Second step would be traditional data or the traditional method. So traditional method is a set of methods that are derived mainly from statistics and are adapted for business. So here comes the role of stats. And also the BI here and stats here together can form the role of business analyst. So this is perfect. Traditional method is just perfect for analyzing future. So we can do future predictions using traditional methods, but not BI. BI is only for analyzing past. All right. So the third process or segment of data science would be machine learning. So we all know that machine learning is about mathematical formula. So these are the approaches that I'm writing here, or the tools that we use. Formula plus say significant amount of computer power. Obviously this is highly required. significant amount of computer power plus artificial intelligence. So together, mathematical formula, significant amount of computer power and artificial intelligence will give an outcome from data without being explicitly programmed. And that is the difference between a software engineer and data science. So there are certain limitations of data scientist because he is not designing a software. That is one difference. Or he's not building a software basically. Okay. Now, let us understand the whole process, starting from when we receive an unstructured or a raw data to processing and getting meaningful information. Because there are several steps that we never talk about. I have always heard about, all right, we get the data, there is processing, and there is a meaningful insight that we draw. But how do we really do it? Please mute yourself, or co-hosts, please help. Okay, so we cannot really analyze any data straight away, especially the untouched data which are raw in nature, because the first step is data collection. So let us understand the step one. Co-hosts, please help in muting the person. All right, step one is data collection. This data collection is divided or can be done in two ways. One would be manual, the other is automatic. So the manual is related to survey. When we manually do the survey, we conduct the survey and conclude. In case of automatic, data is collected maybe, let's say, through cookies, anything other than manual, any other method or way from which we are receiving data. So, for example, through cookies, we can understand how many customers are coming directly to our website. And in survey, we can physically or through maybe a video meet or through telephone, we can understand how many customers are really interested into our website and visit. So data collection gives rise to various problems because as the data is not filtered or processed, or since it is huge, we process the data. After we collect the data, there comes processing of data. But then we do not really process the data right away because there's one more step that comes between collection of data and processing, and that is pre-processing. Sounds simple and related to process, but is actually different because pre-processing will have further steps. So there are various methods of pre-processing, and I'll also tell you why is it really important, because anyway we are processing the data, right? So pre-processing is a technique which attempts to use a group of, I'll rather call it group of operations. So it is a technique which will attempt to use this group of operations, and it will filter the data or give us a structured data that is further processed to give meaningful data. So let us take an example. Let us take a database, say this ID, name, state or place, and phone number. In this data, if suppose we have some data, say, in this data set, let us assume that instead of name, this UK is written, which should actually be here. And this place can only have categorical data, but we have a numerical value here. So it should not be here. And also in phone, it is just this, not a number. So again, this data is not correct. These three are not the correct data. So such errors can be identified in pre-processing itself and can be rectified for a reformed data. So in order to identify, because processing may skip this and will understand what processing is. However, let us first understand the techniques used for pre-processing. So the techniques for pre-processing. First, class labeling. So we label the data. Basically, labeling the data means to correct data point or arrange data by category. Arranging data by category is class labeling. This class labeling is divided into two parts, that is numerical, which will have mathematical value, and categorical. So this data cannot have categorical will not have numerical value. And in the above data set, we have already seen that this place cannot have a numerical value. And that is why we label the data. So at this stage, we will just understand everything. We will get an overview of everything before we dive into it. Okay, so next would be data cleansing. Data cleansing, or we can also say data scrubbing. Suppose, let us understand it better with an example. There's this place, say, let's have, it was supposed to be an O here, but it's E, and how to identify that error? When we had class labeling, we could only understand one thing, that in this data set, in case of class labeling, we understand that it could either be numerical value or it could be a categorical value. And accordingly, we have placed the data. However, if suppose this name or this place is incorrect, that is again another method, another technique of pre-processing in order to correct that data, that one data within the data set. We use data cleansing, and therefore this error is rectified using data cleansing. Last is dealing with missing value. At times so happens, especially while we take survey, or if we get data from some other department of the company, we might get some missing values. For example, if in a data set, the age of the customer is, there are few places where the value is missing. So there we average out the age of every other customer and put it in that missing value. So we here use average. I hope I'm clear so far. Just to avoid confusion, raw data, processing meaningful information is the process, followed by the steps. That is, first the data is collected from the very scratch. We are doing it from the very scratch. Data is collected and is divided into manual and automatic. Then the techniques used for pre-processing, that is class labeling, data cleansing, and missing value. All right. So after this, let's move on to.
Hello.
Yes.
Could you please pardon missing value again?
Sure. In missing value, suppose let's understand it better with an example above. Here in data set, if suppose this was missing, there was no number here. All right, we cannot do this in phone. There are certain restrictions to it. There is an addition column, number of complaints or number of purchase, or maybe say let's understand age. Age is the best that we can understand. If I have certain age, if this person has certain age, and there is nil value, so we will average these two age and figure out an answer or a value to this place. Is it clear?
With that, will be able to bring the accuracy in that?
No, but then since we cannot really go and do the survey again, we may or may not be interested in knowing the age, but a generic age. Suppose if you sell a product, or your company sells product of maybe garments or maybe laptop, and you have to understand how many customers or the respondent who gave the survey, they were interested which age was particularly interested. So if you find one or three missing values there, you can average it out and then a generic idea can be shared. Correct? So it is used then. You do not understand it in a way that these steps are used mandatorily. It is used only when you require it during your project or survey. If it is required, you use it then.
Okay, ma'am.
Okay, so after missing value, these are the only three things about pre-processing. Let us understand the approaches while dealing with data collection, especially in case of traditional data, because we are done with the first part, that is pre-processing, data is collected. Now, the approach that is used while dealing with such data collection. Let us understand. Balancing. Balancing is the approach towards the challenges faced in rectification of data. So suppose if there is a survey say who spends more between men and women, and the result that we get is 20% and 80%. In order to have a balance, so that we have, in order to maintain equal number of respondents, that is women and men, we have to analyze the data further, and to do that we have to ensure that this 20:80 is actually 50:50, and that is how we may chuck some responses that we feel is not important, and that we will have to obviously apply our brain to do that. So we take equal number of respondents in order to apply this approach, that is balancing approach. Next is data shuffling. Data shuffling is more like a deck of cards, because it is a technique that improves predictive performance. So it avoids any misleading data. Because for example, if there is an Excel where we have a lot of data, we shuffle the rows and columns in such a way so that does not affect our data, but will also let us know the misleading result, if any. That is one technique that we will discuss further, especially while we use the database management system. Then these are the only two approaches that we have while dealing with traditional data. And then there is database architecture. There are two types of database architecture. One is entity relationship diagram. The other is relational schema. Just understand it here, because we will eventually learn everything in database, and we will also be making, while preparing our project, we will try to use these diagrams while preparing the reports. So just to understand how it looks, ERD, or the entity relationship diagram, is something like this, where it shows it is a theoretical way of represent. I mean, it's a theoretical way of representing how databases are related. So these are all the databases, and the relationship is explained or showed by ERD, that is entity relationship diagram. The other is also a way of showing the relationship between databases, and that is relational schema. Again, we will study this while doing SQL, RDBMS, and then we'll learn all these things in detail. These are just an overview, as I discussed. Now, one example, let us understand traditional data with an example. Suppose we have one database where we have ID, first name, last name, mail, and complaint number. We have data as well, say something here, something here, and then we have complaint number. Now, in this SQL table, let us assume it to be one. This table is of customer. Let us understand that ID is the primary key, is a unique number, is a primary key, and it can be manipulated or changed. So also, we have one more numerical value here. ID, first of all, is unique. However, complaint number is not, because it can repeat, it can be added, it can be deleted, it can be changed, but ID cannot be. So it is our primary key. We cannot change it. And also, there's one confusion. We always feel that probably wherever alphabet is there, that is categorical in nature. But in reality, this complaint number is also, ID is also categorical in nature. And I'll tell you why. Since, as I said, that we the value of 1 or value of 2 is similar to that of the first name or last name, we cannot really add, delete, or use any aggregation in ID. But we can do that for complaint number. We can add 3 total. If we are asked how many complaints in total were made, so we can add 3 plus 4 plus 5. But we cannot do for the ID. We cannot add 1 plus 2 plus 3. And if we are adding one person, add one more person, total 3. So if we are adding that for IDs, we also do that for first name or the name or the mail IDs. So that is why even this ID, where we cannot use any aggregation, is not numerical in nature, although we have numerical numbers here. But it is not numerical. As we cannot do any calculation, we cannot aggregate, but this, and it is categorical in nature. This here is numerical. So this is one example of traditional data where we, at times it so happens that in interviews we are asked whether this is categorical or numerical, or there's always a question. So understand this one. Now let us understand big data. So far we have discussed about traditional data. Let us move to big data. So although big data is like traditional data, except that it is way more huge and is not limited to numerical and categorical class labeling. So therefore it is different from traditional data. So here class labeling would include not just number, not just alphabets, but also digital images, videos, and audio data. Like yesterday, when I gave you an example of Facebook, where when we receive any data, they are huge in number. And it can be in any form. It can be in video form, could be in audio, text. And so it is really difficult to manage such data and also to store them. And therefore, there are different methods to clean such data. So the first would be text data mining. As the name itself suggests, it is only related to text. So it is a process of deriving valuable, unstructured data from a text. So suppose if number of resources to retrieve data or the text data are huge, then this technique is used called data mining. So here we derive valuable, unstructured data from text. This is text data mining. We will obviously discuss it in detail.
Hello.
Yes.
Sorry to interrupt you, ma'am, but for big data, is there any quantity or something, an amount or to unit it? Like what is called as big data and
It
what
is
is
not
the
defined. There is no quantity, nothing that is defined. A data that can manually not be handled in a way is big data, because you cannot store images or audios in an Excel file, or you cannot work on it manually. But suppose if we have all the interns or all the candidates here in this group, we can actually calculate them, maintain an Excel, maintain a date of entry and exit for them. And that is easy to manage. So therefore, that is part of traditional data. However, if I'm supposed to manage all the records of everyone here in this group, and say the records that I have to maintain is your photographs, Aadhaar cards, or any ID cards. I cannot do that in Excel. At max I can only write the unique number, but cannot maintain it.
Actually, I heard it from somewhere that if data is more than 1 terabyte or something like that, then it is considered as big data, or you know.
It is
So I
natural.
asked this question.
So anyway, Utkarsh, it is natural, but then there is no definition. There's nothing that is defined. Even if it is below that, but however, it is in a format such as I mentioned. If it is in audio file, in a video file, it will come into the category of big data and not traditional data. I hope I answered that.
Yes, ma'am. Thank you, ma'am.
Okay. So next is data masking. So data masking is to preserve confidential data. This is majorly used in government organizations. It deals with confidential matter. So the technique to analyze information without compromising private details is data masking. So it conceals the original data with random and false data. So it allows to conduct analysis and also keeps all the confidential information in a secure place. Used in government organization, but also used in big private companies. All right. So this was all about the technique used for for big data. And as I told, that data science has three segments: BI. Let's go back. So we have BI, traditional method, and machine learning. We'll just try to explore BI more because it is directly linked with business analytics. So again, I'm just repeating that we are going through an overview right now, and we will cover all these things. It is just an understanding so that you understand all the terms in a layman's language. You at least you are familiar with these terms, so that when we use it later in actual scenario, when we process all the data and use it, you know the generic meaning of what it means and why and where is it used. So let's understand again BI and BA. I hope is clear. BI is part of BA. Again, when BI is about analysis, BA is about analytics. So understand, when I say BI, it also means BA. But I'll tell you exactly when is BI converted or changed into analytics, when we can understand it to be a BA's role. So business intelligence is once the data has been processed and is ready for analysis, and it is not raw anymore. It is an organized and a structured data. We can then enter into BI. So the raw data is processed. We get meaningful information, and then we do BI analysis to that meaningful information. So BI is nothing but it requires data skills plus business knowledge plus business intuition or intuition in general. And these things are used to explain past performance. So the role of BI would be not only to think of one solution to a business problem, but will have many angles to the problem. So there will, suppose if there is a data on sale, so we need to understand or raise queries such as how much did company manage to sell in first quarter, or how did it manage to perform good or bad, and such things. So we have to think out of the box and think extra. Always think extra so that you cover or capture every query or any problem so that you are ready with the solution as well. So a BA or BI will analyze the past data in such a way that it will give future predictive meaningful data. So BI will analyze the data in such a way to give, here is the role of BA, because this BA will convert that analysis or the report into future predictive meaningful data. Let us understand or explore the steps involved. Step 1 would be collect observations. That is the data, or let us understand that we have collected this observation here. Observation cannot be put into mathematical manipulations. So we have to quantify this data, and therefore next step is quantification. At observation stage, we are not using any mathematical manipulation or formula. So this is step 1. Quantification is step 2. Here in quantification, it is a process of representing observations as number. So in quantification, we represent the observation into number, and then comes measures. This is step 3. So in measure, we accumulate, it is the accumulation of observations, accumulation of number to give business meaning. It involves aggregation. So whatever data that was converted during quantification into numbers, we aggregate. We either use average, or we may find out the monthly or annual report. Whatever it is, we use aggregation here. So now we have aggregated data. From just numbers to aggregated data, and then comes metric. Step 4. So metric here, number that bears business meaning. So far, there was one thing missing, and that was business attached to that number. Whether sales, so whatever, suppose if there was a sales data we collected during observation, that data was in a raw form that was changed into numbers. We wanted sale, just the numbers of sales, how much sale was done. So the number was received here. The monthly sale, if suppose we want a monthly sale, it was done somewhere here in measure. We aggregated the data and gave the meaning, business meaning to it, saying that whether it was good or bad for the company, and how should we proceed further. That is what metric is. So during observation, any activity to sale can be an observation. For example, you can observe variables such as sale volume or new customers enrolled in new website, where each sale and each customer is considered as a single value. that is in observation. Quantification of that data is a process of representing observations as numbers. The way to tell about observation is quantification. Then measure, as I said, accumulation of number to give business meaning. It will require an aggregation, monthly, average, annual. Lastly, this metric, number that bears business meaning, so that it brings business logic in measure and has business application to it. So in large business transactions, we will have thousands of metrics, and we cannot keep track of all metrics from data set. So though we can keep track of all such metric, but practically it is not logical. We cannot really do that. Okay, and here there's one important thing that we have to understand, that is key performance indicators. Or KPI. I'm sure you must have all heard, many of you must be aware of it, know it better than me. I'll just let you know what it is. Let's say KPI. It is the key performance indicator. Key because it is related to business goal. Performance to understand how successful you performed within time frame. So success within deadline. And indicators, they are values or metrics that indicate something related to your business. Value or metrics. So we have already understood what metric is, and therefore that is the difference between KPI and metric. Metric is part of KPI. KPI is a bigger version. Both are related to the goal, business goals, but KPI also includes deadline, which metric does not. And both will include business goals, but it has a broader goal. Suppose it will also meet the vision of the company. However, in metric, it may only deal with the vision of the product. That is because we worked on the data of that particular product. So this is the key difference between the two. Okay, also we can understand KPI and metric with an example. Say in metric, the traffic of a page from your website that was visited by any type of user could be an example of metric. It is not structured, not defined. We don't know who visited, or we cannot filter out which kind of customers or which type of user visited our website. However, in case of KPI, suppose the traffic is generated only from users who have clicked on the link provided in our ad campaign. So we know which kind, where did we actually share such a link. So it is defined. We can at least filter it out in KPI. I hope it is clear so far.
Ma'am, could you please repeat?
Is it too much to understand, too much information, or?
Ma'am, please elucidate this.
What, Utkarsh?
Please elucidate the difference again between metrics and KPI.
Okay. I hope you understood what metric is and how we reached from observation to metric. Is it clear?
Yes, ma'am. Yes. Yes, ma'am. Absolutely.
So metric would require business goal. And through metric, we understand whether that product or that observation is good or bad for the company. I hope that is clear. We can relate it with the product goal or the business goal. Yeah.
Yes, ma'am.
All right. So in KPI, this is KPI, and this here is metric. Very simple thing to understand. Maybe a product goal is just to meet. Suppose if we take an example of Lenskart, there's a new product in the market that says that it is only, I saw a recent ad of Lenskart which said that it is only for vintage or the vintage look. So probably there the target audience would be only maybe vintage look will be preferred by some college students, somewhere around 17 to 22, or say say old age, because probably they will have that taste. What about others? So this will have somewhere around, let's say 55 to 70, somewhere around that. What about others? KPI on contrary caters to the business goal, that is to cater every age group. So company's vision is larger than the product's vision or the goal of the product. Is it clear, Utkarsh and others?
Sure, ma'am.